Okay, Sudoku puzzle, there might be one on your exam. So I'm not going to spend too much time on this, but remembering your strategies, you can kind of do two things. So for an example, I might look at just ones. Okay, if I do something like that, my idea is like for here, I can figure out where the 1 would go in this box. Okay, I can see a 1 on the bottom here, on the top here, so I'd have to put it in the middle. But then I can't do that there, so okay, I can also figure the 1 out in this box. Here's why. So I can't put the 1 here. I can't put the 1 there. I still have 2 options, but I know. So here's how I know. Down here, I can't put the 1. So I would have to put the 1 in one of those boxes, which means can't do it there. So you see how I used a little bit of a problem-solving strategy? And then I can keep going with ones. So here, this box, we can't be in the top, we can't be in the middle, we have to be on the bottom. But there, and then on the last bottom box here, the left bottom, I can't be on the left, I can't be on the right, so I have to be in the center column, but not here. So right there, which leaves me with that. Okay, so that's one kind of strategy. The other kind of strategy is you can take single boxes or single rows or single columns. So I could isolate this box and I could be like, well, I need a 2 in there, a 5, an 8, or a 9, right? Those are the 4 items missing. Well, I can't put the 8 in any of the 3 bottoms. So that's an 8. Okay, moving on. Are we good with Sudoku? You got some strategies, right? It just takes some time. Okay, maybe grab your cheat sheet. Maybe grab your cheat sheet. You have your cheat sheet ready? Okay, so logic, you have Venn diagram stuff on there. So we talked about using the word and, using the word or. And is in an overlap, or is across any place. So on this one, here's the one that's tricky, is that this is an and statement with 2 things, but if you already have a value in here, then make sure you minus that. So 7 is the overlap here. 2 people happen to overlap another thing. So you have to account for that. Okay, so let's see what it looks like. Where do I start? Which kind of statement do I always start with? 6 people use all 3 apps. So 6 goes in the middle. I need some kind of and statement. So I can do this one. 10 people use Snap and Facebook. So do you see where Snap and Facebook overlap? It looks like a football. I need 10 people in there. So 4. Did you get it? Because there's already 6 in there. These 6 use Snap and Facebook already, but they happen to also use Instagram, but they're already in there. Okay, the bottom one, 14 students use Instagram and Snap. So Instagram and Snap would be this little football. So I have 6 there, so I need 8. Because in that football shape, I need 14. And then there's another and statement here, 3. But this statement is different because it says the word only. 3 students only use Instagram and Facebook. So I'm actually just put 3 there because of the word only. Okay, I'm going to now go to some kind of single statement. So a single statement, 30 use Instagram. So I need you to look at the whole Instagram bubble, and you need 30. So 8, 6, 14, 3 more, I'm up to 17. So I need 13 more, and then that whole circle will add to 30. Here's another single statement. 25 use Snapchat. So kind of hide that. You only want the Snapchat circle. So I need 25. So 6 plus 4 is 10, 18. 7 more. The last is the ors. So you go in this order. So Snap or Facebook. Can you visualize what that looks like? Anything I've shaded in here is an or, Snap or Facebook. So all of that has to add to 30. So 6, 4, 8, and 7 was 25. Plus 3, I'm up to 28. So I need 2 more in that. So if you need anything extra on your cheat sheet, I looked at this logic. I did ands, I did singles, then I did ors. Okay? I'm telling you there's one on there, so on your exam. Question isn't answered. How many students only use one type of technology? So where on this diagram would you see people only using one thing? These people use one of them because these people are in an overlap, which means they're using multiple. So 13 plus 7 plus 2. There's 22 that use only one type. Okay, you got a couple little tiny things in your cheat sheet that you want? there might be some students that don't use anything. What did you all add up to?
Like
43. So if I ask the question, how many students don't use anything? 7. Technically, when you get to grade 12 and we do this, we would also do that, because Hunter said all of these numbers added to 43, but there was 50 students. So 7 didn't use anything then, right? So that could be a question too. How many don't use anything? Okay, you're only allowed to use these digits, and you got to make this puzzle work. So here's your starter spot. That has to add to 22. So I'm up to 16 plus 6 more. Okay, I'm going to cross it off because I can't use the 6 anymore, right? Is my math bad? Is your math?
No, I did not.
Okay, I'm going to tackle this box next. Because 6 and 8 is 14, and I got to get up to 18. So I need 4. Scratch off 4. Okay, that's it for direct. So now we got to do some logicking. Okay, where do we want to go here? 7 plus something something makes 13. What would these two letters or numbers have to add up to? 6? Okay, so what are some options left here? What could I use to go with to add to be 6? 5 and 1. I just write them small because I'm just telling myself these are some options. Oh, I can eliminate something. Does anybody see what I can eliminate? Looking at this across now. What do you think? No for the 5. Why can't I use the 5? I'm already past 7. If I do 5 plus 4, I'm already at 9. That's not good. So we can conclude where the 5 and 1 are going to be placed. And then you got the rest. You need to put a 2 and a 3. Okay, I don't think you need anything on your cheat sheet because it's going to be figured out. Okay, can you write those words on your cheat sheet? Can you write inductive, deductive? Those words, I want them on your cheat sheet. Okay, what's the difference? Deductive uses truth, definitions, inductive uses patterns, observations. Okay, so that's the difference. One uses concrete evidence, and the other one uses some observations, okay? This one is the concrete, for sure, definite. Students at Olivia's high school have to have a B average to play sports. Olivia has a B average, so she concludes that she can participate in sports. That is deductive. Sorry, I should have used this word actually. Facts. Deductive is all about facts, and these are facts. Holly notices that every Saturday her neighbor mows the lawn and today is Saturday, therefore the neighbor is going to mow the lawn. Inductive observations and patterns. If Alon stays up late, he will be tired the next day. Alon is tired, therefore Alon stayed up late. That is inductive. That is bad logic. What's wrong with that? That's not really good logic because there could be other reasons to be tired, right? If a number is divisible by 4, then it's divisible by 2. Is that true? Yes. 12 is divisible by 4, therefore 12 is divisible by 2. Were those all facts and definitions? Those were. Okay, so did you have those 2 words on your cheat sheet good for how you want them? Okay, 2 angles are complementary if their sum is 90 degrees. That's the definition for complementary angles. Angle 1 and 2 are complementary, thus, what kind of conclusion would you make? So 2 angles are complementary if their sum is 90. Angle 1 and angle 2 are complementary with each other, thus, what? Thus, they have a sum of 90 degrees. Right? Okay, you're going to tell me if something is true or not true. It tells me this triangle is the same as a circle, and this square is the same as a circle. Therefore, the square would be the same as the triangle. Yay or nay? Is that good logic? Is that, yeah, that would be true. If you're the same as a circle and you're the same as a circle, then you're equal to each other as well. Yeah. Chad is a human. Trump is a human. Therefore, Chad is Trump. No, yeah, false. So why? Explanation. There's more than one human. Some people in this class are people who have attended W&M, which is a school. Some former U.S. presidents are people who have attended this school. Therefore, some people in this room are former presidents. Would that be a true or false statement? False. Can you explain why? Well, more people would go to that school than just presidents, right? There'd be other people that go to that school as well. It's not just a school of presidents. Okay, many mammals are not human beings. Okay, that's true. There's other mammals out there. All students in the school are mammals. That's true. Therefore, some students are not human beings. That's false. They aren't connecting their logic ideas properly. Okay? They aren't making that connection. Okay, if a polygon is regular, then all of its sides are congruent, which means it has the same side lengths. So that is a definition of what a regular polygon is. It's a shape where all of its sides are the same length. All sides of this polygon are congruent, thus this shape is a regular polygon. Yeah. They used good connections in their logic. Okay. Here's a statement. So they did a bunch of math, and then they said, thus, when you times an even number by an odd number, the product is odd. So you can see what they did here. They did 6 times 2 plus 3, and then they did 6 times 2 plus 3 equals 15. Is there a problem with what they were trying to prove? Did they make any errors? Yeah, which one did they do here? They made an error in their calculations. Where is the error? Right there is their mistake, because what would you have to do? 6 times 3. They didn't do that. Jane likes blueberry muffins. Blueberry muffins have blueberries in them. Jane doesn't like muffins without blueberries. So which mistake would you say this is? So I have some definitions here. If you have an error in reasoning, you're just not connecting right. If you have a faulty logic, you're just no connection at all. She's trying to connect ideas, but not properly. So an error in her reasoning. All teachers drink coffee in the morning. Sarah is a teacher, so Sarah drinks coffee every morning. So that is a faulty assumption, because you're assuming that all teachers are drinking coffee, which they don't, because I don't. Jake does not go to school on the weekend. It is the weekend, therefore Jake is going to go play soccer. So that is a faulty logic. There was never anything about soccer in the original, so you can't conclude anything about soccer. No connection. Okay, conjecture was a word we used to say, hey, what's happening? Okay, so here's me multiplying 9 times 1, 9 times 2, 9 times 3, 9 times 4, etc., etc. So can you notice any patterns about these values? What's happening? Can we make a pattern observation? And you don't have to pick something that's true or not true. It doesn't matter. I just want you to say, here's what I'm kind of observing. Anybody want to make a pattern observation? Okay, here's what I always think. These numbers look like they would go 1 plus 8, 9, 2 plus 7, 9, 3 plus 6, 9, or the front digit is going up, so 0, 1, 2, 3, 4, 5, and the last digit is going 9, 8, 7, 6, 5 down. What do you want to say? Because there's a few patterns. So the digits add to 9. So that's my conjecture. I'm like, oh, this looks like it's happening. What do you think about my prediction? Is it always going to be true? No. My pattern isn't going to always be true because, give me an example that's not going to happen then. If you kept going here, what are you going to get to? What's 11 times 9? 99. Do its digits add to 9? No. Counter examples are when you show me something that disproves. So I said when you can square a number, you're going to get a bigger number than where you started. That's not true. So you have to show me why. Can you square a number and then it doesn't get bigger? What do you got? What's that? Decimals. 0.5 squared is actually 0.25. So decimals, and 1 squared didn't get bigger. And there's one more example. 0 squared doesn't get bigger. Okay, and that's it. Decimals don't. All birds have wings, therefore all birds can fly. It's not true, so you have to show me with an example of something that proves that. Penguins.